Hello everyone, welcome to day 15 of competitive programming, and today we'll be solving yesterday's contest questions, that is others 59. So we'll be opening our timer first, and let's start our timer, and let's open CoachF. Here actually we have solved one question today for so that we'll maintain our streak. It's compete, and we'll be solving starter 79 in div 3, and I have decided I will be participating on this contest. So let's open better deal question, and actually I have solved this question. It's a pretty simple one. This is the one I have solved it for today. Off the screen, well, I'll just simply read the question. Two stores in Chefland, they have given the 100 rupees. One shop will selling for 100 rupees, other shop will give selling for 200 rupees, and they'll give the discount A and discount B. Now after subtracting the discounts, you need to print which shops gives the which shop is selling the item for the less amount. If it is first shop, you'll print first. If it is second, you will print second. If both are printing selling for the same cost, then you will print both. So that is what you are doing here, and that's the easy one. Actually, I have recorded this how to solve, how I solved this, but I just lost the recording of it. There was some technical error, and the video was not saving properly. So I have started again recording everything. Thank God it was just I realized in the first 10 minutes, so I have started recording it, restarted the recording. Anyways, now let's change the directory cp, and let's create our new file, this.pp sums.cpp. Okay, now they're saying, let's see the question here. Given an even integer n, output a permutation p of length n such that the value of p of I plus p of n plus 1 minus I is existing for all the values of. It is guaranteed that a possible solution always exists. If multiple such permutations exist, print any. Note that permutation p of length n consists of all integers from 1 to n exactly once. For example, permutation while is not. So they'll give the input, they'll give the number, and we need to print the array. Oh, actually there is a constraint, right? P of I just forgot it. How I'm thinking just they are giving n value and we are printing the array from 1 to n. Well, that's not the case. They are saying the first number, and this means the last number, right? That means they are saying for 1, 3, 2, 4, 5, 6. 6 plus 1 is 7. 3 plus 5 is 8. 4 plus 2 is 6. What if we just take the array 1, 2, 3, 4, 5, 6. 6 plus 1 is 7. 5 plus 2 is also 7. 4 plus 3 is also 7. So we cannot take in this way. They just change these two numbers. That's what they did in 1, 2, 3, 4 also. They just change the first two numbers, and here also they just change the first two numbers. So what is happening, even if we change the first two numbers here, that is 2 and 1, 3, 4, 5, 6. What is happening here? So 6 plus 2 is 7. 5 plus 1 is 6. 4 plus 3. Okay, 6 plus 2 is actually 8, my bad. 4 plus 3 is also 7. Okay, so it does actually work if we just print 2 and 1. And the constants here are t's and n value is only 2000. So we cannot solve it in n cube time complexity. We can only solve this in n square time complexity. So let's take our snippet and we'll remove the array from it since we only need the integer. And n will be initially 2, right? So of course we need to print, we'll just print cout 2 and 1 because it is necessary to print them. Then we'll take a for loop and we'll start from 3 which is less than 1, and we'll print all the elements that is I. We need to go up to 6, right? So it is less than or equal to. Now let's compile this and let's take our test cases and let's now we got the answer 21213 and 456 2134. Okay, this is not ended actually. We need to give spacing after the for loop. We need to print it. That's it, right? Now clear, let's compile now and let's take all these numbers as input, and we got 21213456 and 2134. Let's copy all this and let's paste it here and submit. It is the wrong answer. We have gone wrong in the second test case itself. Only there are 2 test cases and we have gone wrong in the second one. Should we write a for loop to print 2 and 1 also? No, right? Because here we are getting it properly. This and I is less than or equal to n by 2. So what am I missing here? This said output and space separated into a permutation p of length, and note that a permutation p of length consists of integers. Here it is. It is guaranteed that a possible solution always exists. If multiple such permutations exist, print any. Should I do in this way? Okay, let's test case where the number is 2, 1, 3, 4, 5, 6. Now 10 plus 2 is 12. 1 plus 9, 10. 3 plus 8, 11. 7 plus 1, 2, 3, 4. Okay, 7 plus 4 is also 11. And 5 plus 6 is also 11. So apparently we need to change for all those numbers also. So we'll just print all these numbers in reverse order, numbers which are less than 2, uh, which is 5, right? So we'll say 5 4 3 2 1 and 6. So now this is 15. 9 plus 4 is uh, 13, and 8 plus 3 will reduce by 2 numbers, and 7 plus 2 is 9. 6 plus 1 is 7. So that's it, right? Yeah, that's it. So we'll just print all the numbers in reverse up to n by 2. Okay, we'll start from n by 2 and we'll be saying greater than or equal to 1 and I minus minus. Excuse me, I'm so sorry. Now n by 2 will start from here and I will be less than or equal to n and I plus plus, and we'll be printing high value, of course. Now let's go with the given values and let's print it. Now it is 0 1 2 1 3 4 and 1 2. Okay, 1 2, it doesn't matter for 1 2, right? Yeah, now it got submitted, obviously. So let's go to add a smallest prime factor. And it is at 1272 rating. Let's close this. Let's create a file and primefact.cpp. So chef current score is x. Each second chef will find the smallest prime factor of his score and add it to his score. Okay, for okay, every each second. Determine the minimum time in seconds after which his score becomes greater than or equal to 9. So let's take our array snippet itself, but we'll remove the array from it. And let's say the variables are x and y. For each test case, output the minimum time in seconds after which chef score becomes greater than or equal to y. And these are the constraints. They have given. Initial the score is 2, chef needs to score to be at least 23. The smallest prime factor of 2 is 2. Thus the score increases 4 is 2. Thus the score increases 6. Similarly, each time the score will be increased 2. Thus after 11 seconds. Okay, 9. For 9, the smallest prime factor is okay, for every element we'll find the smallest prime factor and we'll go on increasing it by those many times, right? So let's create int small factor, let's say SPF, smallest prime factor, and it does take a number, and first we need to find the factors and we need to whether check it is the smallest prime factor or not. How are we gonna do this? we have 2, 3 and 5. Okay, and x value will be less than or equal to 10. That's what they said. So we need not have this, right? X value will be 2 less than or equal to 10. So if it is let's say 4, prime factor is 2. If it is 5, the prime factor itself is 5. And 8, 2 is the prime factor. 6, 2 is the prime factor. 7, for 7, 7 itself is the smallest prime factor. So shall we go with the test cases? So I'm thinking to write the if cases, or is there any other way? We are having 2, 3, 5 and 7 as prime factors, right? So let's take this as an array, and we'll check if the given number is divisible by any of these numbers. If it is divisible, then we'll take that as the increasing number, and we'll be multiplying it or adding it until we get the required number. So time complexity will be n. So let's take int prime is equals to 2, 3. Okay, it's an array. 2, 3, 5, 7. For int I equal to 0, I less than n, I plus plus, it is not less than n, it is 4 itself. And if x is divided by any of the numbers, then we'll say okay is equal to 0. Then we'll be saying that is the smallest prime factor, so sum equal to 0. Sum is equals to prime of y. Now we got our sum value, so we got our 9 value. Now int difference is equals to y minus x. We need to fill those by numbers. So we can divide it, but we need to get the closest. We can use ceil function. The ceil function gives int answer is equals to ceil, means if answer is 2.5 it will give us 3. So ceil of diff divided by sum. Sum is the number which we are taking to add, and we need to print the answer, right? Expected. Okay, apparently we forgot a semicolon, which is responsible for our code to crash. We got 10/3/1927. Okay, it is the each second, right? Each second is the number of times. So let's just say int answer equal to 0. For int I equal to 0, I less than an I plus plus, or we'll say while diff is while diff and we'll be saying diff minus equal to our sum, and every time we'll do that we'll increase the answer. We'll say while difference is greater than 0. We'll be doing this. Now let's just compile, copy all these variables and paste it here. We got level 4, 19 and 28. Wow, why are we getting the same? Okay, 5 is given. 100 is the number we need to reach. So 100 minus 5 is 95. So 5 and 10. Okay, for 10 the smallest prime factor will be only 2, right? So you need to add 2. I mean, any number you add to itself, it will be prime factor will be 2 itself. I forgot this logic. Like, but if we are having 9 and the prime factor of 9 is smallest for 3, so 9 plus 3 will be 11. For level, prime factor is 11 itself. So okay, for second test case is 3, thus the score is increased to 12. Okay, 9 plus 3 is 12. Next is 2, 14, 2, next is 2, next is 2. It's not the difference you need to calculate. It is now x is equals to sum. Now we have our sum. After getting the sum, let's take number 2, its prime factor is 2. Okay, number 3, its prime factor is 3. 3 plus 3 6, again divisible by 2. Let's take 4. 4 is 2. 4 plus 2 is 6, again divisible by 2. 5 is 5, and double it, you'll get 10 divided by 2. Again it's the thing I'm saying is, for the first time you'll find the prime factor and you will add it to the sum. For the next times the prime factor will be 2, since because all the numbers are divisible, it is turning into even. So I'm checking whether it is true for everything. For 6 also it is 2 and it is turning into even. For 7 it is 7. 14 for it is also turning into even. And 8 is 2 again. 10 is also even. For 9 it is 2 3 again. So 9 plus 3 is 12, which is also even. And that's it. Do we have n value 10? Yeah, 10 also. 10 is 2 and 12. So you'll take this answer variable and put it here. And after getting the sum, I guess I'm just overcomplicating the solution, and you will say answer plus equal to sum, I mean y minus x by 2. Is this correct? G plus plus dot slash a dot out. Okay, G plus plus. I don't know which the time it is, but I am apparently trying to compare the a slash a dot out file. We got 9, 4, 45 and 40. So there is a slight mistake which I need to Should we say here seal? No, we shouldn't say. It doesn't matter, I guess, because we know that all the numbers we are getting are divisible by 2. The point is, even you cannot solve this question in order of I guess you can solve it in order of n. You can take a for loop and you can keep adding 2 to the x value. If it is less than, you will break. If it is not less than, you will not break. I mean, while x is less than y, you need to keep doing this. You need to increase the answer by 1 and also increase the x by 2. Same question, but we changed the approach. There we got 10, 9, 45, 40 before, and we got okay, it is 9, 4, 45, 40, and here we got 10, 4, 45, 40. Okay, what did change the question here actually? I mean the solution, what affected our solution? So I'm just thinking, what is the mistake we are doing here? Okay, we still have 30 minutes. Okay, what is the mistake we are doing? We are finding the factorial, but it is okay. Let's also print the prime, some value before adding to it, and also print the x value. Now let's just compare. For test case 2 and 23, x is 2 and I mean prime is 2 and x is equals to 4. Then the answer is 9. If x is 4, the number to reach is 23. So we added 2 to the x already. Next we need to add 4, 5, 6, 7, 8, 9, 10, 11, 12, so on. We need to keep adding. That is 23 minus 4, which is 19. 19 divided by 2 is yeah, like I'm trying to trace how did I get 9. Y minus x by 2. Y value is same, which is 23. 19 by 2 is 9, 10. But we got only 9 here. It is 10, right? And after adding here, we need to also increase the answer value, because we added the sum to it. Dot same 1 2 23 2. Okay, we need to compile it. 1 2 23. Now we get x value as so we need to go for even and odd. So in that case okay, let's say if y percentage divided by 2 is equal to 0, we'll do this. Else answer plus equal to sale of y plus 1 minus x divided by 2. Okay, I plus equal to clear, compile prime factor, and just print here. Let's copy all this and paste here. We got 46 41 level and 5 46 and 41. Why for the last case we are getting some other value? Yeah, here we are getting 2 12 3 6 5. What are the extra things we are printing? That's it, right? Did we remove? Okay, we remove the x plus equal to some line. Now we got level 5 46 and 41 42. We need to get 42, but we got 41. So what is the problem with 6 and 89? 89 minus 6 is 83, right? So we need to find with which what is the prime factor of 89. Don't say 89 itself is prime to. Okay, we need to prime the smallest prime factor for 6, right? So which is 2. That's it, right? So we added the 2 to 6, which is 8, and answer plus so answer is 1 now. And 89 is not divisible by 2, so 90 by 2 is what we need to do. So 89 plus 1 90 minus 8. 90 minus 8 is 72, and 72 divided by 2 is 36. That's it, right? We are finding the prime number, and after finding the prime number, the number is turning into an even number. So if it is an even number, of course its smallest prime factor will be 2. Sorry for I was just adjusting my mic. So that's it. We got stuck here for this low rated question also. I mean comparatively just less rated. I'm just thinking, what is the thing we are missing? Apparently, few people has actually solved this. In the contest itself, 3,143 people solved this. So I should be able to solve this. What is the mistake we are doing here now? Okay, if we reach level, if we reach another prime number, then we do only the smallest factor of it, right? Initially you are doing good, but when 89 is itself prime, you will be reaching a prime number that is something like 17. So what will you do in 17 case? You will just add 1 and you will add 2. You cannot do that. Should be the smallest prime factor. That means we'll just remove all this. Let's have a sum variable and a line to print the sum. So here we'll take the variable x and we'll just try finding the I'm just thinking how to find the smallest prime factor, because finding that we can find a number, we can then check that number is a prime number or not, but the time complexity will be huge, I guess. So let's write our function to check whether it is a prime or not. Int prime, int n, for int I equal to 0, I less than n, I plus plus. Let's start from 2. If n is divisible by any number that is less than n, then we'll return 1. If 1 is not written in any case, then we'll return 1 actually here, and here we'll be returning 0, indicating that it is false. Now we have our function to check prime or not. Now we'll go for smallest prime. So for int I equal to int smallest prime factor, int n. Next we'll say for int I equal to 1, I equal to 2, I less than n, I plus plus. So you will calculate int smallest prime factor for every number. So less than n. If there are n numbers, then you will check for using this n loop whether it is prime or not. Then you run this. So isn't it more than n into n into n, where n cube? Let me check SPF after this. If n is divisible by a number we need to find the first prime number by which it is divisible. That's it, and we'll return it. If n is divisible by I and I is also prime, then we'll just return the I value. That's it, right? So now we'll get the I value. Now we'll say while x is less than y, you'll be adding it SPF, and what is the value we're gonna pass? We need to pass x itself. That's it, right? And we'll count the number of seconds. Warning. We actually did close it. Did close this. Even this is also closed and pretty. Okay, here we are not returning anything. We are return I if t is divisible. Okay. Return n itself. If it is not divisible by any number, or if it is not a prime, smallest prime number. Okay, it is apparently just a warning for us, so no problem there. Let's copy all this and paste here. We got level 5, 46 and 42. There we have solved this. Submission is queue right now. Actually, how many questions did we solve? Okay, only 2 of them we have solved. Yeah, we got TLE as expected. Actually, here we can do it n by 2 times itself, and here also n by 2 times itself. Okay, we have reduced the number of operations by half. I hope we will be getting still TLA because it anyways does not increase n by 2. Yeah, if we find a prime number, it will be less than NTL. The problem is for every number, for every time you are increasing it. Okay, once x becomes even, then we'll not call the function. That's it, right? We'll just add we'll add 2 to the rim or ceiling. Okay, we'll do that. We'll add the ceiling, right? Ceiling of y minus x by 2. Okay, so only if x is not, we'll do this if x is not even number. We'll be saying x plus equal to SPF of x, else we'll just say okay, answer plus plus is right here, right? Else we'll just say break, and we'll say answer plus equal to ceiling of y minus x divided by 2. And here y minus, because if it is only even, if it will just break out of this loop. Now let's compile prime fact and let's check whether it is giving. It's given 10, 5, 47 and 41. for one the value has been increased, for the other the value has been reduced. It's because here let's reduce and let's break. I feel like it is being double time added if it is even. Okay, 9, 4, 46 and 40. So that is not it. Okay, it is pretty much sad that we got stuck in 1200 question. We got 10, 5, 47 and 41. What is the mistake we are doing here? 10 instead of level. Why are we getting 10? Also just say x plus equal to 2. That's it. Now let's just compile and run it. We got level 5, 47, 42. For this it is 47. For 5, smallest prime factor is 10. Sorry, for 5, smallest prime factor is 5 itself. Adding 5 to 5 will get 10. Next for 10 it is 2. Next to 12 it is 2. 14, 2. So 10, okay. Let's also subtract that thing from the 100. We need not do it that if we add it for x, it is enough. So initial x is 5. So initial x is 5. Next x is less than y, so and x is not divisible by 2. So we'll find its smallest prime factor. Here we'll start from 2. 2 is not divisible, and 5, right? 5 by 2 is what is the value of 5 by 2? It is 2. Okay, we'll just have here equal to. Okay, here it should actually go till n now, because its prime means the only number that can divide itself is n, right? So let's now compile prime fact and let's copy all this. Let's paste it here. We got level 5, 46 and 42. This is the correct answer. Let's copy all this and let's paste here. We try reducing our questions and complexity by reducing the number of operations we are performing. Let's check will it help any a bit or not. Still we are getting TLE. Okay, we'll find a way to solve this question more efficiently tomorrow. For now, let's try doing a new question. 1 stone or 2 stone? 2 stones. Okay, this is higher written, but let's just read the question. Jeff and Jeffina are playing a game. There are 2 piles numbered 1 and 2. Pile 1 contains 6 stones, while pile 2 contains 5 stones. Jeff starts the game. In his turn, Jeff can either remove 1 stone from both the piles or remove 2 stones from one pile. On the other hand, Jeffina in her turn can either remove 1 stone from each from both the piles or remove 2 stones from pile 2. The player who cannot make a move loses. Determine the winner if both players play optimally. So optimal in the sense that the player 1 should remove 2 stones. There are 2 piles, number 1 and 2. Okay, player 1 done. 1 stone from each pile, or remove 2 stones from pile 1. Okay, you can remove 2 stones. Oh, I'm so sorry. You can remove 2 stones from pile 1. Chef 1 in his turn can remove 2 stones from pile 1. And other player can remove 2 stones from pile 2. Who cannot make a legal move or remove a stone fails to win the exam. I mean, fails to win the game, right? This is also a very interesting question. Let's score it for now. Who's gonna win, we need to print their number. So at least we'll be coding. They have 8 more minutes. So atom1 or 2.cpp. IOStream. Okay, let's just use bit/std++.h using namespace std int main in test cases. After reading test cases, we'll be calling our function solve, and inside our function solve we'll be reading 2 numbers. That means the number of stones in pile 1 and pile 2. So if player 1's turn, should I maintain a variable called turn also? If the turn is even, who is going to make the first move? Let's guess Chef is gonna make the first move and Chefina is gonna make the second move. So the variable t is equals to 1. If it is okay, if t is odd, then Chefina does the first move. Should we run a loop to do this, or can we do this without having a loop? X and y values are to the power of 9. So my approach in my mind is for every 1 turn we'll be solving it, we'll be subtracting it optimally. Whether if we can do remove 1 stone from both the piles, we'll remove 1 stone. If it is not possible, then we'll remove 2 stones from our pile itself. And similarly for the case 2 also, until x is not equal to 0 or y is not equal to 0. Okay, we'll say if x is equals to 0, or less, if f is less, x is less than or equal to 0, then we'll just say what are we gonna do here? We'll print we are lost, right? Who is lost? Chef is lost. That means Chefina is the winner. CHEF Chefina. Okay, if she is the winner, then else y must be have been 0, so Chef is the winner here. Okay, after having the winners, if uh, if t is even, then okay, we'll go with odd first. Then it is chef's turn. In chef's turn, if x is greater than 1 or equal to 1, and y is also greater than or equal to 1, we'll subtract from x and also will subtract from y. Okay, if that is not the case, then we'll just subtract 2 from the x itself. Okay, that is for the if case. If it is odd, then we'll check on the other Chefina turn can either remove. Okay, here also it is the same. But here it is y minus equal to 2. Okay, now if we are doing until x is greater than or equal to 1, so if x is equals to 1 and y equal to 1 also, we can subtract based on the turn. That's it, I guess. Let's compile 1 or 2.cpp and let's take the sample inputs. Let's run, giving the sample inputs. Okay, what is happening here? We entered into an infinite loop. It is because it is less than or equal to 0, or y is less than or equal to 0. Actually it should be and. Both of them should be less than or equal to 0. Now let's compare 1 or 2. Let's just get time sample input. We got Chefina and Chefina. One more time. Why is that so? For one test case, 4 and 2 are the values given, and we got the answer as chef. And why is this thing is jumping? Okay, I'm not reading the x and y values. That's the mistake I'm doing. Okay, dash a dot out, giving the values. It is chef the winner always, not Chefina. Okay, if x is less than or equal to 0, chef can remove 2 stones from pile 1. The player who cannot make a move loses. Determine. Okay, if pile 1 becomes less than 1, so if x becomes less than 1, then Chefina is the winner. Okay, based on the turn you have to say, right? So we'll say see out answer. If it is our turn, I mean if it is not even, it is chef's turn, right? In chef turn, if x is less than 1, okay, if x is less than or equal to 1 and y is also less than or equal to 1, then we'll just say answer equal to, not chef cannot. Okay, timer is finished. Now Chef cannot make a move, so Chefina is the winner, right? So answer equal to 1. 1 indicates Chefina is the winner. So let's just say if it is 1, Chefina, else will print Chef. Okay, this will be our last attempt to solve this question. Okay, if the same applies to Chefina also, we'll make it 0 and also will break, because her moves are exhausted. Okay, now let's compile and hope there will be no errors. Yeah, we got few errors. They are saying int declare is Nokia. So int answer equal to will declare with a 0 initially. After compiling, after taking the sample test cases, we got the same output. Anyways, we'll be solving these questions tomorrow. We'll be try solving them. For today, I guess we only solved a very basic question. That's it. Anyways, we'll be solving these 2 questions tomorrow also. So thank you. That's it for today.